In this lesson, you will learn how to graph quadratic functions in standard form. The first step is to determine whether the parabola opens upward or downward. For a quadratic function in standard form, if a is greater than 0, the parabola opens upward. If a is less than 0, the parabola opens downward. For our function, a is 1, which is greater than 0, so the parabola opens upward. Next, find the axis of symmetry, which is a vertical line that divides the parabola into two equal halves. The formula for the axis of symmetry is x equals negative b over 2a. For our function, a is 1, b is negative 4. Substitute these values into the formula. This simplifies to 2, right? Therefore, the axis of symmetry is the vertical line x equals 2. Next, find the vertex. The vertex lies on the axis of symmetry. So, its x-coordinate is the same as the axis of symmetry. To find its y-coordinate, substitute its x-coordinate back into the original function. This simplifies to negative 9. Therefore, the vertex is the point 2, negative 9. Next, find the y-intercept. The y-intercept occurs when x equals 0. So, set x to 0 and solve for y. This simplifies to negative 5. Therefore, the y-intercept is the point 0, negative 5. Next, find the x-intercepts. The x-intercepts occur when y equals 0. So, set y to 0 and solve for x. Let's use the factoring method. We need to find two numbers that multiply to give negative 5 and add up to negative 4. We know that 1 times 5 equals 5. But if we make 5 negative, they multiply to negative 5 and also add up to negative 4, right? Therefore, when we factor this quadratic equation, it becomes x plus 1 times x minus 5. Next, set each factor equal to 0 and solve for x. Solving the first equation, we find that x equals negative 1. Solving the second equation, we find that x equals 5. Therefore, the x-intercepts are the points negative 1, 0 and 5, 0. By the way, if you want to master how to find the axis of symmetry, the vertex, and the x and y intercepts of quadratic functions, please check the links in the description. There are videos for each topic with plenty of examples. Now that we have almost all the points we need, the next step is to plot them on the graph. The axis of symmetry is the vertical line x equals 2. The vertex is the point 2, negative 9. The y-intercept is the point 0, negative 5. The x-intercepts are the points negative 1, 0 and 5, 0. Now we add one final point, which is symmetric to the y-intercept across the axis of symmetry. Notice that the y-intercept is 2 units to the left of the axis of symmetry. And remember, the axis of symmetry divides the parabola into two equal halves. So, a point 2 units to the right of the axis of symmetry is also on the parabola. This point is 4, negative 5, right? Finally, connect these 5 points to plot a parabola opening upward. In this example, we were able to easily factor the quadratic equation when finding the x-intercepts, right? However, this is not always the case. Sometimes, factoring can be difficult or time-consuming. Even if you use the quadratic formula, the discriminant might not be a perfect square or could be negative. So, what should we do in such cases? Let's see that with this example. First, determine whether the parabola opens upward or downward. A is negative 1, which is less than 0, so the parabola opens downward. Next, find the axis of symmetry using x equals negative b over 2a. A is negative 1. B is 6. Substituting these values into the formula, we find that x equals 3, right? Next, find the vertex. Its x-coordinate is the same as the axis of symmetry. To find its y-coordinate, substitute 3 for x into the original function. Simplifying this, we find that y equals 6. Therefore, the vertex is the point 3, 6. Next, find the y-intercept. Remember, the y-intercept occurs when x equals 0. So, set x to 0 and solve for y. This simplifies to negative 3, right? Therefore, the y-intercept is the point 0, negative 3. By the way, the y-intercept always equals the constant term. Now, if you try to find the x-intercepts, you will find that the quadratic is difficult to factor. Even if you use the quadratic formula, the discriminant is not a perfect square, so you may need a calculator. In such cases, instead of finding the x-intercepts, we can use other points. Let's first plot the points we already have, and we will come back to that. The axis of symmetry is the vertical line x equals 3. The vertex is the point 3, 6. The y-intercept is the point 0, -3. Also, locate a point symmetric to the y-intercept across the axis of symmetry. The y-intercept is 3 units to the left of the axis of symmetry, right? So, a point 3 units to the right of the axis of symmetry, which is 6, -3, is also on the parabola. Now, to find other points, take an x value that is closer to the axis of symmetry and determine its corresponding y value. Let's take x equals 1. You can also take 2, which is even closer to the axis of symmetry, but it is easier to work with a smaller number, which is why I preferred 1. To find its corresponding y value, substitute 1 for x into the original function. Simplifying this, we find that y equals 2, right? So, we have the point 1, 2. Plot this point on the graph. Now, just as we located a point symmetric to the y-intercept across the axis of symmetry, we also locate a point symmetric to this point across the axis of symmetry. This point is 2 units to the left of the axis of symmetry, right? So, a point 2 units to the right of the axis of symmetry, which is 5, 2, is also on the parabola. Now, connect these 5 points to plot a parabola opening downward. Notice that in both this example and the previous one, the parabolas cross the x-axis twice. But in the next example, we will see a case where the parabola touches the x-axis only once. Please feel free to pause the video and give it a try. Since a is greater than 0, the parabola opens upward, right? Next, find the axis of symmetry. A is 4. B is 12. Substituting these values into the formula, we find that x equals -3/2. Next, find the vertex. The x-coordinate of the vertex is -3/2, right? Find its y-coordinate by substituting -3/2 for x into the original function. Simplifying this, we find that y equals 0. Therefore, the vertex is the point -3/2, 0. Notice that the y-coordinate of the vertex is 0, which means the vertex is on the x-axis. Remember, the x-intercept occurs when y equals 0. So, the vertex and the x-intercept are the same. This happens when a quadratic has only one real solution. Next, find the y-intercept by setting x to 0. This simplifies to 9, right? Therefore, the y-intercept is the point 0, 9. Now plot these points on the graph. The axis of symmetry is the line x equals -3/2, which is the same as -1.5. The vertex is the point -3/2, 0. The y-intercept is the point 0, 9. Also locate a point symmetric to the y-intercept across the axis of symmetry. The y-intercept is 1.5 units to the right of the axis of symmetry. So, a point 1.5 units to the left of the axis of symmetry, which is -3, 9, is also on the parabola. Notice that even though we know the x-intercept, which is the same as the vertex, we have only 3 points. But when graphing a quadratic function, I recommend having at least 5 points to plot a decent parabola. So, to add 2 more points, take an x value closer to the axis of symmetry and find its corresponding y value, and then locate a point symmetric to it across the axis of symmetry, just as we did in the previous example. You can take x equals -1. Then find its corresponding y value by substituting -1 for x into the original function. Simplifying this, we find that y equals 1. So, we have the point -1, 1. Plot this point on the graph. Then, locate a point symmetric to this point across the axis of symmetry. This point is 0.5 units to the right of the axis of symmetry. So, a point 0.5 units to the left of the axis of symmetry, which is -2, 1, is also on the parabola, right? By the way, if you want to make your graph more accurate, you can add more points like this. But 5 points are good enough to plot a decent parabola. Finally, connect these points to plot a parabola opening upward. Now, let's look at our final example, where the parabola does not cross the x-axis at all. You can determine the direction of the parabola opening, the axis of symmetry, the vertex, and the y-intercept, following the same steps we used in the previous 3 examples. I will leave the answers and you can pause the video to work on the calculations. If you have any questions, please feel free to leave them in the comments below. Then, plot these points on the graph, and also locate a point symmetric to the y-intercept across the axis of symmetry, which is 4, -11. Notice that both the vertex and the y-intercept are below the x-axis, and we know that the parabola opens downward, which means the parabola does not cross the x-axis. So, this function has no x-intercepts. This happens when the quadratic has no real solutions, which occurs when its discriminant is negative. Another similar case is when both the vertex and the y-intercept are above the x-axis and the parabola opens upward. Now, just as in the previous 2 examples, you have only 3 points, so take an x value closer to the axis of symmetry and find its corresponding y value. If you take x equals 1 and find its corresponding y value, you will have the point 1, -5. Then plot this point on the graph and locate a point symmetric to it across the axis of symmetry. Finally, connect these 5 points to plot a parabola opening downward. Thanks for watching. I hope you found this video helpful. Please give it a thumbs up and consider subscribing.